This is parametric modeling for drainage. 8 o'clock session, 2022 partnering conference, FHWA and KYTC. All conference attendees, please make sure you sign in with the registration desk, so you'll receive training credit. Please download the conference app from the App Store for a detailed agenda. Search for and download the Crown Compass Events app. In the Crown Compass Events app, search for 2022 ACEC, KY, FHWA, KYTC Partnering Conference. For assistance with the conference app, please go to the conference registration desk. The preferred method of evaluation is in the conference app. Your name will be downloaded from the app once for each evaluation you submit and placed in the collection for the drawings. You will be entered in Wednesday night's drawing once for each evaluation you fill out. Please fill out one evaluation per breakout session. Participants will be allowed to win only one raffle prize. If your name is called again, you may claim the second prize, but you must return your first prize. The first prize will then be raffled again. Wednesday's lunch will be from 11:30 a.m. until 1 p.m. in Grand Ballrooms A and B. Wednesday night's reception will be from 4:45 until 7 p.m. in Grand Oaks Ballroom A and B. The reception will include the vendor hall, prize raffle, snacks, and cash bar. The pink drink ticket located inside your badge will be honored at Wednesday night's reception. The speakers for this morning's session are Tim Robinson. Tim has 26 years of KYTC roadway and drainage design experience. He previously worked as a consultant and has worked on a variety of projects providing both roadway and drainage design. Tim is married and has 3 children, enjoys running, martial arts, and watching University of Louisville basketball. Erika Smith. Erika is the drainage liaison for the Kentucky Transportation Cabinet in Central Office for Districts 3, 6, and 9. She came to Central Office Drainage Branch after aiding in the development of the QRD workspace and designing projects across Kentucky in the developmental branch. She has designed several projects across Kentucky, from simple bridge replacements to urban roadway design. She wants to continue working with teams across the state to improve their work performance. Alan Esguerra. Alan, PE, is an industry strategy manager at Bentley Systems, responsible for tracking industry trends, identifying solution opportunities, and working closely with the transportation industry and development teams to continually drive innovation. He came to Bentley from the consulting world, where he served as the U.S.-based regional national technology leader, working with various agencies to deliver better highway design projects. He has worked at several global and national engineering firms, experienced in delivering conventional PS&E projects to 3D models for design and visualization on a range of traditional and alternative delivery projects.
Can y'all hear me okay? I'm going to start out by asking, please raise your hand if you actually use ORD. Okay, now raise your hand if you use ORD drainings. Not as many. How's it been going for that? Okay, well, we are working on trying to make that workspace better. What we're going to start out with is Erika is going to be telling us about some of the updates to have a little bit of what's going on and what we've got coming, to try to help you out, and then we'll get into the parametric cells. So, Erika.
So we all know that the policy states that all new starts for roadway projects are to begin in ORD. City Office Drainage prefers that all new starts begin in ORD drainage as well. We at the very minimum, we prefer that all structures be at a minimum laid out in ORD, which means pipes, culverts, inlets be laid out. Even if they're not hydraulically calculated in ORD.
Can y'all hear us okay?
Yeah, can you? So ORD can provide new hydraulic and hydrologic elements, which means they can do rational runoff and storm sewer calculations. We have included storm sewer calculations and some spread analysis. We have not approved, forward analysis, so please continue to use AQI for forward analysis. We have actually, now, gotten, inlet head calculations to work now that we have, gotten the ditches to be better feature definition, with the new release of the Oregon, standards. And now to, talk about parametric cells.
So has anyone used parametric cells before or are familiar with it? Okay, we got one. I see. Okay, so why are we talking about parametric cells? Does anyone know what parametric cells are? We'll cover that. If you do, raise your hand. Okay. All right. So the current workflow for ORD EU is to create an individual cell or pair of cells for every single node. And creating those cells and a combination of cells is a big pain. So has anyone ever had to create any part of that workspace or had to create their own cells before? I see a lot of ORD users or something. If no one has done that, it's okay. But it's, you know, an important skill to probably learn how to do if you need to create something that's not available in the workspace. So the problem with this method is that it takes forever. You could potentially have thousands upon thousands of different combinations depending on your state. Because you guys have a lot of different standards, a lot of different combinations of top and bottom nodes for your vaults or your inlets. So what parametric cells are these kind of special cells that you can create using variables and equations and definitions that are kind of grouped into variations. And so what that means is, you know, you guys create your standard detail sheet and you have, you know, a box that has all these dimensions on it. But when you're using regular MicroStation, you're just drawing boxes by hand and it has no smartness to it, right? If you're used to using civil cells or civil cells, or even just anything, you know, civil related with ORD, there's a lot of these like rule-based geometry, rule-based design that you apply. But for this is rule-based design for regular MicroStation elements. So if you're used to creating solids or 3D elements with old MicroStation, just know that if you're doing this in ORD, it's there's a lot more smartness that gets added to it automatically, and that might bulk up your file, but it also makes it a lot easier to modify later. So the reason we're doing this is because we can create one parametric cell that can serve hundreds, potential hundreds of different variations that we would then use to create the EU individual figure definitions. And we can do this using Excel. So instead of having to go into each and every cell individually, modifying it, potentially creating a whole lot of like trial error, like human error by going in and stretching, maybe I stretch in the wrong direction, maybe I got to key in the wrong value. I can kind of automate a lot of this using Excel. So we'll go into some examples, but pretty much parametric cells will create, you can create a parametric cell that reads an Excel spreadsheet and plops in all the different variations we define. So here's an example of using parametric modeling in a bridge scenario. And so this is kind of required for certain bridge features. Has anyone ever used ODD or ODM? And so in this case here, we have a parametric cell created for different parts of the substructure, right, for this bed. And I'm just going in and selecting different parts that I had already created and type in a variable. Oh yeah, that one I had one. So as I'm changing some of the values, you can see it automatically changes right there. And so I didn't have to go in and create a fence and stretch or redraw or reproject anything. I had already figured out how it's supposed to act, and now I can key in the value for that. So an example of where you could potentially use this in EU is obviously forward head walls, where you have a lot of these dimensions, right? These standard variable dimensions that you can customize into your parametric cell. So it looks more familiar to you. You know, your Z value might be different than my Z value because I don't do work here, but you can customize it any way you want. So here's an example of one of your detail sheets, and you can see you have all these different variations. You have A through J or T, or A through Z. And so this is kind of what it looks like. So on the right, you see your 3D side. On the left, you see kind of how it looks like. You have all these different kinds of microstation constraints, and you can go as crazy or as simplified as you want. You can use this for 2D or 3D. And here I'm just changing some of the values for the wall thickness. And you can see that it's a lot thicker. And after I change some of these individual values, I can save them as a separate variation. So it's a group of variables. So if I know that 12 variables change between one version and another version, I can save them as different variations. Now remember, this is just microstation cells. So there's not anything smaller. And you have a lot of different options where I can hide the different constraints. I can hide the different dimensions. You can see there, I typed in wall thickness equals 12. Or 10. So other examples are slope from under head walls. I mean, it's really anything three-dimensional or two-dimensional that you typically draw over and over again, which is a definition of what a cell would help you with. But parametrics adds that smartness to it. Now, there's a lot of tips and tricks that Erika will go through later, but if you start playing around with it, you can see how it can be very powerful and kind of streamlining some of the tests that you may do. And you can use this for not just the use it for bridge, you can use it for anything really microstation. You see a lot of mechanical engineers kind of gravitate towards this, or mechanical modelers, because they're used to doing machining and a whole bunch of different variations for different optimizations. But this will definitely apply in scenarios where you have a lot of details. So here, yeah, I'm just going in and selecting different variables, and it changes a bunch of the groupings, and you can do the whole width, and, the size, and the positioning. So to show you what it is, if someone's ever looked at it before or done it before, this is the very basic definition of a parametric cell, or how to create one. So I'm just creating a box. I don't know if you guys can see that. You guys can see that. I'm just drawing a box. And I'm creating a new variable. So I'm just going to do X, Y, and Z. And here I'm defining what those variables are. So I drew them and created variables, and now I'm going in and applying those variables to the different pieces of the box that I created for the square. And microstation and open roads by default has all of the same modeling capabilities, and 3D modeling tools and features. And so I extruded that up. And now I'm going to apply the Z value to that extruded. And now when I go and change some of the variables, I do this a test. I create a variable, I apply it to the microstation elements, I move it around, I test it. That's going to be very important if you start messing around with this. I can turn on my constraints and my dimensions, and then I'm going to create a variation, which is a group of variables. So it really is kind of simple, right? But this looks like it takes a while, especially after you do 1,000 of them. And so I hit the check, move it around, I change some of the variables, I change the variation, and I apply it to see what it looks like. I'm constantly checking. And so what this looks like, if you don't use the U, this is a inlet cell. I mentioned before, you can export this to Excel. Really, that's one of the key parts of doing this, or of using this in terms of having a Excel sheet. So here I just created a bunch. You can just copy and paste it. If you have a PDF that has it, defined for you, or you can create equations, right? You can create mathematical equations. So if your whatever definition or detail sheet that says this is an equation of another variable, you can apply that here as well. So part of the problem, or part of the challenge that we face, is that right now DU has like kind of a bunch of these different separate pieces. You have to create all these individual cells. parametric cells can help streamline the process of creating those cells, but you still kind of have to apply it into a kind of a useful format for ORD. And so there exists a VBA in which you can take one variable or say one or multiple parametric cells, and it will create an individual cell, a dumb, static, old school microstation cell for you to be able to utilize with DU. In the future, we hope this will go away. See a lot of flashing in the background. Well, pretty much what this does is it goes down on the Excel spreadsheet. It says, place this variation in this one model, create a new model, go to the next one, create the next, drop the next cell, put it in. You know, so it does this kind of like loop process to the end of the Excel spreadsheet. And so if I had to create a bunch of cells for a DOT and I had 1,000 of them, and I know that I had say like 1,000 different variations, I wouldn't have to manually go in and into every single model, every single cell, and modify every single one. I can instead create one cell, spend all this time creating one cell, drop it in, use my spreadsheet, use the parametric cell capabilities, and streamline the process that would normally take about a week, maybe 2 weeks, maybe a month, down to a day, maybe 2 days. So in the future, parametric cells will look a lot more, or will be used a lot more effectively with DU. But currently, right now, in the current available product, this is pretty much what it looks like. So this is for anyone who hasn't used DU before. And so it's all kind of like 2D/3D based. I have my 3D on the right, my 2D on the left. And here I'm just placing a node. This could be a head wall, this could be an inlet. You notice here, putting it in the 2D and defining its rotation and its placement. I can even define, its elevation, or if I'm reading a terrain or a proposed corridor. And in the right, it automatically places the 3D plane. Does this look familiar to anyone? So I did want to illustrate that I used the terrain model as the z-value the first time. In the second, in this one here, I'm using a proposed ground. And if it's rule-based, so that means if I created an inlet and I dropped it on top of someone else's proposed corridor that's being referenced in, someone else is working on that. If that corridor seems to change profile or super elevation, my inlet should update with it if I have the right checkboxes. If I wanted to, right? Sometimes you want it to automatically update, sometimes you don't. And so in this case here, I may not have wanted it to be automatically updated if someone changed it, but it's easy. I can just go in and change the value and say, hey, I need to make sure that my elevation reference is the asphalt surface, and it moves up. And here I'm just placing on a manhole for a junction. And so after you place it, we want to get away from this idea of deleting and withdrawing. So after I place it, maybe place on one. I want to try to avoid deleting it because there's some smartness or some intelligence to it. It's kind of a practice that we should try to learn with ORD. Much different than the older versions of the nerds where there's a lot of delete redraw because the data is really some of the images. But here I just went to the properties and I changed it. So I changed the node from one feature definition to another, one junction to another, and it changed. And I'm doing everything right now on my 2D on the left side, but you can see that it's automatically being placed as a 3D in 3 dimensions. And it's also automatically choosing profile for me based off of some of the defined parameters I have. And I may not want that, right? How often do we let the software just do everything on its own the first time? So I open up the profile view of one of these runs. I hit the 3D cut button and I can see the cross sections for everything. Or I can see all the cross geometry. Anything in the 3D model I can see in my profile, my cross sections. So I wanted to make sure I had enough clearance between some of my crossing types, some of my crossing utilities. And all I did was went into the individual run at one pipe and I changed the profile. I changed the profile. And you can do this a number of ways, right? So some of these might be static. I might have to change a pipe, or maybe I need to change the inlet depth. But you have a lot of flexibility in modifications after it's placed. And if you update it in your plan view or your profile view, it will automatically update in 3D. So this is different from inroads where you had to process something and display it. You had to go through each clicks. This happens automatically. And here I did the same thing. I can see my bridge, I can see some pipes, crossing pipes, I can see the asphalt pavement, make sure I have enough clearance under the asphalt pavement. So there's a lot of other examples that we have for both DU and parametric cells, but if you're interested and you guys are copy this, if you want to take a screenshot or something with the QR code, there's a lot of these tips and tricks, but we're always open to a lot more feedback. If you guys have any questions or if you think we can do something a little bit better, please let us know.
So some tips and tricks that we found helpful were to make some hover lines. These hover lines help develop the parametric cell so that you don't have to completely constrain the parametric cell. This way you can constrain it to the origin 0, 0, 0. This video shows constraining some hover lines to 0, 0, 0, and then constraining it perpendicular and then rotating it. The video goes kind of fast, so I'm just explaining what's happening. I'm just drawing some lines and then drawing it at 0, 0, 0. Then I'm going to constrain it with a fixed constraint at 0, 0, 0. And then I'm going to constrain it with a perpendicular constraint just to have them rotate together. And I'm just going to move them to show that they're actually constraining 0, 0, 0. Kind of went fast, so sorry about that. And then you can actually constrain your parametric cell to that line. This video shows drawing a cell and then constraining it parallel to one of those hover lines, and then it will rotate with that. I'm just going to draw a box and then extrude it. And then train it parallel to one of those hover lines, and then move one of the hover lines, and it's going to show that the cell actually moved with the hover line. And this helps just keep everything clean and where it's supposed to be. As Alan mentioned, as you develop all these variables, you want to test them often. You want to not change too many things at once because you could break things and not notice. So this video shows testing a variable in different ways just to test to make sure that it works. So here I'm just changing a variable to make sure that it works. Changing it to 2 and 3, 4, make sure that it's expanding the way it's supposed to. You want to do this often to make sure that nothing breaks. Another thing is, since you're working with 3D objects usually, you want to make sure that your view is in the correct view. Because if you're constraining concentrically, you may not be able to constrain something to the correct face of an object. So say I want to constrain this red circle to the back of this object. I can't do that because I can't actually select the back of this piece or to the back of this view. So this video shows that. So I'm trying to select the back of it, but I can only select the face of it. So I have to rotate my view. So be very careful with how you've got your view oriented. And then also you cannot concentrically constrain circles to non-circular objects. So say you're trying to get the punch out for a pipe in the head wall, you need hover lines to help figure out where that center or where that pipe needs to be if you've got a multi pipe head wall, because you cannot concentrically constrain that to go to the back of the head wall. Also, do not merge solids. I know it looks nice, but it will break the constraints of the parametric solid. Also pay attention to your error messages. This will help with your testing of your parametric solid, because you can over constrain your parametric solid, and it's happened to me before, and I've had to unconstrain it completely, or unfortunately either start over, as Alan has gotten frustrated with me, and then also set marks for undo, because this can also help with testing. This sets a place in the file for undoing too. This can help you to not have to completely start over. So if you've got a place where you're pretty good with your parametric cells, set a mark and then start and continue to test it. And then if you mess it up, you can undo to that location where it worked.
So the set to undo, this isn't new, this has been in the product for like 20 years. But it's kind of like you are the weakest link. You guys familiar with that? Is that show still on? I don't know. But yeah, it's like you know, you make progress and then you lock it in and you get that profit.
It's like a save point in a video game where, okay, I made it through this section of the video game and I don't have to do it. Hey, save this point. So if I screw up against the bad guy later, I can use this point. Same thing.
Yeah, it's helped me a lot to keep from redoing. I'm a start over type person, and it helped me from starting over from scratch.
So, really, why are we doing this? Well, why are we promoting this, or why do we think that this could help? It's really because that bottom quote, and I think it's from Abraham Lincoln. I don't know. I googled it. Can't tell the something on Google, but if I only had an hour to chop down a tree, I'd spend the first 45 minutes sharpening my axe, and that really kind of embodies what this is. I've had to do thousands upon thousands of these different kinds of cells the old-fashioned way, and parametric cells have been in microstation even in V8, V8i, but in ORD, or at least in this Connect version, it's a lot more stable and it works a lot better. And I never really connected the two until I thought maybe we could just use some of these the combination technologies that they have in the two different products. But it has significantly helped a lot. Now, if you only have 3 cells to create, it's probably not worth it to spend all the time creating a parametric cell, unless you think you're going to use it later on for much more. But if you have hundreds of these, or hundreds of custom proprietary types of 3-dimensional objects that you could use as helpers for designing your roadway, or designing your bridge, or designing your drainage system, this could help you get there a little bit faster. So is anyone familiar with how to create the drainage utility workspace? Or how ORD workspace is working? It's a little bit different than V8, than airlines. You don't have to memorize any of this because you'll get a copy of it, but this is kind of like a high-level breakdown of how DU workspaces work, or really open roads in general with focus on DU. But you have your element template, which is just your microstation, how it looks. Then you'll go and create cells, which is that whole parametric cell part that we talked about. You'll develop your individual 3-dimensional cells. Then you'll create something called feature symbology, which also governs how it looks. Your feature definitions, or your annotation definition groups, kind of define how things will automatically or semi-automatically annotate. Your item types are for additional annotation, or it could be for pay items. Really, it could be any other potential metadata. We've seen people from all around the world using item types for all kinds of things, all kinds of metadata. I think Australia has like 150 different types of item types that they would have to add to any one individual item as a requirement. Now, After you get through item types, now we're diving into the haystack, the drainage properties, which is familiar, if you guys are familiar with the old drainage stuff, catalogs and prototypes. That kind of governs how you have a hydraulic model. So we didn't really talk about it. I talked about model, right? But there's all different kind of models. When I talk about parametric cells, this is all microstation model, geometric models. But then when we start talking about DU and hydraulic models, that would dive into the setup for the catalogs and the prototypes. Once you have all those things set up and defined, then you create your feature definition that governs how it works. It encompasses everything else above it. So block number 8 is your last step. Oh man, I had this really cool. Anyway, so that's your hydraulic prototypes, and then your feature definition is your absolute last part. Why are we telling you this? If you guys don't ever really use this, is because you see something that you need to customize, or you see something that's missing from a project you need. This is a basic foundation of how it works, so that you can go in and maybe copy something and modify a little piece.
Let me interject right here. And so we're talking about parametric cells, and they're great, and they can set out all these cells with minimal work. You realize if you're gonna make them usable and be used, you gotta go through steps for each array still. Now, Bentley's aware of this. They're working on automating the rest of this, process as well, but just be aware if you have something that we have created, you feel like these parametric cells, and you want to use it in drainage utilities, you have to go through the rest of this for each cell that you created, so there's still some drilling down to work on. So, yeah.
So this is how it looks like in the product. So if you open up the Explorer, just kind of like the Inroads Explorer, you kind of dive into it, but you go to the Open Standards, this is where you define a lot of these things and go through some of the steps. And then when you click on each one of those individual pieces, you'll have additional properties to them. Now, like I said, if you got to create a custom one, it's probably better to copy one that's the most similar and modify it. Unless you're very familiar with it, comfortable with creating brand new out of the box definitions.
So some other interesting things of the ORD drainage workspace is that we have a little bit more expansive workspace than SS2 storm sanitary, and we're working to expand it even more each day. We want to include parametric cells as well. We've got a couple in the works. We've got at least overall RCBC, and we've got a slope miter pit wall. And then we've also want to include every bit of the standard drawing for the workspace. And we also want to include non-standard stuff such as the slope miter pit wall. And we've also have worked on item types for future annotation. We currently can't use item types for annotation, but we have it in the works for the current standards. So it's there, so please look for it in the microstation properties, but we can't use it for annotation yet, unfortunately.
So clearly we have a little bit of ways to go, but we're going to continue producing a whole bunch of enhancements. There's going to be focuses on using parametric cells with drainage and have to be a little bit faster, a little bit easier to work with. And then also hopefully creating streamlining the creation of prototypes. If you guys ever had to create that in the hydraulic part, we didn't talk about that, but the hydraulic prototypes part is also kind of arduous. There is also performance improvements and things that we like to call the single source of truth scenario. So you have different data sources, but if you think about it, like inroads and microstation were sources of truth. You always had to update the old inroads or you update the microstation graphics from whatever you designed in inroads. And so that's kind of a process that's we're trying to make better or move away from. That's where you see that in ORD. where instead of having a separate database, a separate file, a separate program, that handles the data, then you have to always update it in migration. As you see now, which some people are, like the old, Safeway. But now that roadway portion is a single source of truth within migration or within open rights. Unfortunately, it's still a little bit different in EU, where you have multiple sources of truth, and we're continuously working towards making sure that there are a lot more integration with that. And then also symbology improvements, making sure that we have more flexibility in how things are displayed or annotated. And then just continued improvements on that whole workflow between open roads and then open flows. If you guys have ever heard of open flows, that's kind of like a more drainage oriented or hydraulic oriented product that DU and ORD is kind of supposed to take care of a lot of most of 100% of transportation drainage projects. But open flows has a whole lot more other stuff that I'm not familiar with. By the way, I'm a roadway guy. I'm not a drainage guy. So all the drainage questions, that's you guys.
Me. No, yeah. So kind of short this off, kind of summarize this. First of all, we are really working hard. I know one of the frustrating things when we were in SS2, going sanitary and all that was small. We had a lot of stuff missing from the standard drawings, right? So again, like Erika said, and let me say, Erika was Erika could join this part thing for this gets in. So thank her when you get the final get this. But we are working to make sure we try to get everything that's in the standard drawings and not just cell wise, but actually with all the background information working with you. So you got to ask what beyond cells and what look like parametric cell. We talked about the slopes and binders, and the one I worked with was an RCPC, a cast in place. We all know the process with the cast in place. Is we make our estimate of what the dimensions are going to be on it, put it in, and then we're told about structures what we did wrong, and structure complexity. Here's what it's supposed to be, and you go back and have to remodel it in. We're going to have the parametric cell in there that's got all the basic parameters in there. So what you can do is, I don't know, I've got a spreadsheet I use that I still don't care, to be honest. That helps me kind of get an estimate based on the way it's laid out. So I'll put my best guess in there. And then what I'll do is I'll three-dimensionally, and this is something you do with any of the cell, is, and you do it in SS2, but it's a little more prevalent in SS3, is you can see your existing proposed surface and what stream is, embankment for a head wall, for example. And rather than try to guess what the whole parapet you're trying to do, you can actually visually see it and actually just place it in there. Okay, so I've got this head wall that I made my best guess at, and I think a pretty good guess of where it needs to go, the stream on both ends. So I can put that in. I just punched in my parameters in the parametric cell, bang, there's my cell, I'm putting it in. Now I've got those central structures, and I can actually, modify, okay, I need to modify this. And I would like to say that you can go to that cell once you put it in and modify it, but you have to go back to the main parametric cell and redo it. But I think that's something that is actually working on as well. I'm not sure. But you bring that cell, that revised cell in, okay, now I think I've got where it is, structures. Okay, well, here's the modification you want to make. You come up with that final cell, if you punch in the parameters with it, instead of that stretch, and then you put parameters in, bang, drop it in, there you go. So there is still use for parametric cells, even though we provide a lot of these cells for you. Just again, keep in mind those 8 steps that are involved in getting a parametric cell with the cell where it's actually usable to you, final. Other things we know that you all have problems with productivity as far as making a plan set. And we know that's just generally for authority, not just the drainage. Bentley is constantly working to help us fix that. We've been working with Robert Garrett, who helped us create the gym library. Who's been doing the training. Continue to work with him to come up with the best methodology and workflows to be able to produce a set of plans. That's an ongoing thing. We're getting ready to load up the soon, I think, probably. And we're going to have item types in there. we're gonna do something, and we're gonna have some updates on the item types, the next one, afterwards, because depth issues, I think, but, this is really a powerful tool. Let me encourage you to use it. It's gonna have a learning curve, and I realize it's a learning curve for Bentley as well. I'm working, I can actually say there's a group of state drainage users at the hydraulic conference, that they did a hydraulic conference. And we've actually got a group together, that we're actually going to Bentley and saying, here's the issues we have, you know, one that we know again is that the headwater's not calculated like everything by things, you know, going on, but we're trying to work through that with them. And there's other issues as well. Some we had workarounds on that we're working with Robert to teach you, some just have to be fixed. But theoretically, someday ORD drainage, the vast majority of all your design is going to be able to be done in the program. You're not going to have to jump out, go to each way, go out, jump out. Hopefully someday there's a channel line analysis, you know, shear analysis in there. That's something I keep pushing for. It'd be great. You'd be able to do everything in there, be able to print out all these flex tables we have. We don't have these flex tables. They're essentially the summaries that we asked for. And you're going to send it in along with your PGN, and we're going to be able to review it, just looking at the PGN and the tables. The vast majority of it, you know, it would be a simple submittal that goes right along with what we're asking for as far as drainage submittal information. So I realize it's kind of scary. I realize it's something new, but I highly encourage you. We're actually probably going to push sometime in the next few months to make it mandatory to do. Right now, we're just strong encouragement, but you have to do it. Don't do your design and ORD anyway. So we're thinking in the next few months we'll probably put out something that says you have to do the drainage and ORD drainage as well. With the exception, you know, you still have to do the HY and channel line analysis externally, but get all the actual physical data and as much of the hydrology as possible. Let me see if I have anything else. I don't have anything else. Do we have any questions? Yes, sir.
Early on, you mentioned there was issues with deleting the parametric cells. What are those issues and what do we need to do if we do need to delete them?
That's so the question for anyone online was is there any issue with deleting the cells? Because you mentioned that we strongly discourage deleting cells. That was more of a best practice, and you can go ahead and feel free to delete the cell. Let's say you went too far, you created a whole bunch of constraints, and then you created variation, and it exploded. It totally did something you didn't expect it to, and you can't track it back down to where you made a mistake or where it's kind of unfolding on itself. There's something called degrees of freedom. So if you're familiar with parametric modeling and putting constraints on three-dimensional objects, there is a degree of freedom that you may have, like you could potentially explode and change different ways if you have too many degrees of freedom, right? So if I constrain my X, Y, Z's in different directions, but I have other variables that are feeding into that. There's a kind of like with modeling, if you guys have, maybe you guys haven't, but if you guys have started modeling or seen some of your younger staff dive way too deep into modeling, like going in and modeling all the curve ramps where you don't really need to, your return on investment is pretty low on that, and they're spending hours upon hours on doing that. You probably don't need to do that. Same thing with parametric cells and degrees of freedom. You don't have to really get it super tight to where you have 1 degree or 0 degrees of freedom. But we do want to suggest that you try not to delete and redraw all over and over and over again. Utilize the set mark, utilize the undo mark, and also testing your variations as you go along. So you're not completely wasting your time. There's a lot of times where it is kind of an old school method that I would do in inroads, or geopack or microstation. I would go in and make a whole lot of changes and then hit the process button and then realize, oh man, I made like 5 mistakes that I can't go back to. So it's that similar situation. Test often, but feel free to delete and redraw if you completely messed it up. You can't go back to it, but it will set you back. So that's kind of a best practice, but something we have to do.
Yes, sir.
Now, this is a little off topic, but maybe a couple months ago, you had mentioned about the update of the drainage guidance manual. Can you give a status on that or where you are on that?
And you know, you and I have talked about that already.
Well-
I'm kidding. The actual drainage manual, yeah, that's something that's on the list of my things to do. But what I'm hoping, it is my hope, now let me say this, I used to give David Moses the hardest time, dude, what is taking you so long to update this manual? I cannot tell you how many times I've apologized to Mr. Moses, which is so hard to do. Anybody knows David, that's a hard thing to do, is apologize. It's, I actually have a set of training video or training sessions I need to get together. I have a training sessions I'm trying to get together for all of our district designers and all of you all as well, that we just go through the basics of how to design a project. I think that we're going to actually take and put it on our design YouTube channel, that it'll be referenced whenever. Once I get done with that, then I'm going to start in on the drainage manual rewrite. I'm hoping to be talking about that to you next. Anybody else? That is a good question. I thought I told you that the other day. I'm sorry. Anybody got any other questions? Thanks again. So, dive into this. It's going to be some frustrating times. So this is going to be a really powerful. We're redoing the training because we really are pushing, and so we're retaking the training so that we are better at being able to review. But I can tell you, actually, I don't know, the comments been made several times. It just has such potential to be so powerful. So I highly encourage you to start utilizing the drainage utilities within ORD and make that switch over as quick as possible where you can. Anybody else? All right, great. Oh, God.
Thanks.
Thank you.